In this video we have another trig substitution. States if z is equal to tangent of theta over 2, we want to show that sine of theta is equal to 2z over 1 plus z squared. So you'll use this type of substitution in more advanced math courses, say Calculus 2. And in this case it's nothing more than an identity. So I'll start, I want to show that sine theta is equal to 2z over 1 plus z squared. Or, same thing as showing that 2z over 1 plus z squared is equal to sine theta. So I'm going to start with the right side and show that it gives you the left side. 2z over 1 plus z squared is equal to, and then I'm going to make the substitution. It should equal then to z, which is, by the substitution, is tangent of theta over 2. And that's over 1 plus z squared. That's the same thing as tangent of theta over 2, quantity squared. Now we have an identity that tells me that whenever you have 1 plus tangent squared of an angle, that's the same thing as secant squared of the angle. In this case the angle is theta over 2. Now this square here, I could put it right in here. Same thing. So the identity is that 1 plus tangent squared of an angle is equal to secant squared of that same angle. And then we have an identity that tells me that the tangent of an angle is the same thing as the sine of the angle over the cosine of the angle. So in this case the angle is theta over 2. So I'm just going to say I'm going to replace the tangent of theta over 2 by the sine of theta over 2. And this is over the cosine of theta over 2. In this case the angle is theta over 2, and that's over. So remember the denominator now is secant squared of theta over 2. And the secant and the cosine are reciprocal, so I could replace this secant squared by 1 over cosine squared of the theta over 2. So I got this quantity in the numerator divided by 1 over cosine, so I'll just rewrite that and say this is the same thing as 2 sine of theta over 2, and this is cosine theta over 2, and that's divided by 1 over the cosine squared of the angle theta over 2. So I simply take the reciprocal, and this comes out the same thing as times the cosine squared of theta over 2, and this is equal to, and then I'll bring it up here. So notice here I have a cosine of theta over 2, and over here I have a cosine squared of theta over 2, so this one divides out one factor of the cosine here. So again, this was divided by 1 over cosine squared, and then it's just multiplied by cosine squared, or multiplied by the reciprocal, the same thing. I can put this over 1. So what this comes out to is 2 sine theta over 2, and then remember one factor of cosine here canceled out, so this is just cosine theta over 2. And remember I want to wind up with sine of theta. So there's an identity that tells me that the sine of twice an angle, I'm going to call that angle x, so 2x, is equal to 2 sine of x times cosine. So this works both ways. If I start with the left side, I can say the sine of twice an angle is equal to 2 times the sine of half the angle, which of course half of 2x is x, and the cosine of that same angle, x, half of 2x. Going back the other way, if I have 2 times the sine of an angle times cosine of the same angle, that's the same thing as just the sine of twice the angle. So I'm going to go this way. So in this case, I get 2 sine theta over 2 cosine theta over 2. So here the angle is theta over 2, so according to what I just said, this should be just the sine of twice the angle. So it's 2 times theta over 2. Now simplify further, this is equal to sine of, and let's just simplify this. 2 times theta over 2. We cancel the 2 here and the 2 here. This comes out to theta, and that's what we want to show. So all this problem involving the trig substitution is just basically justifying or proving an identity, trigonometric identity. Thanks for watching. We'll see you next time.